And we are live, at least I think we should be live. Welcome everyone to this 5th episode of Building a Visual Inspection System Completing from Scratch. This is the 5th live. I haven't done lives for a while because I wanted to focus on other aspects of building software, but some days ago I made a post on YouTube. Let me show this post. So asking what would you like to see next? And this was your answer. So I said I'm a bit busy and I'm thinking to bring something next. Live streaming about building AI and industrial inspection system, new video tutorials about detection segmentation, and dedicated videos of building complex systems. 42% of you ask live streaming, and so here I am. Before I go further, please chat, let me know if you hear me properly. I have a different microphone today, so I'm not sure everything is working well. It's part of my life, always having technical problems at the beginning all the time. So please chat, let me know if you're watching already. I don't even know, I don't see how many people are connected. Let me know where are you following from, and let me know if you hear me. In the meantime, I'm going to look for the stream on my screen. So here, so I can see also my stream and making sure that everything is working correctly. I think everything is working correctly. So what's different today? Today we're going to make a big change on the software setup. Just to give you I'll start an understanding of what is this. This is an open source software called InspektLine that you can find on github.com, Pysource.com, InspektLine. You see it right here already. 70 people put the stars on it. So if you want to stay updated about this software, you can put a star. You can fork this if you want to take the code and adapt it to your project. There will be 2 versions of this software, a complete free open source version with basic features that you can have access on InspektLine, github.com, InspektLine. And there will be also a more advanced version, more enterprise version, would be a paid version where we'll have more things for companies. So for example, running the system on small onboard devices. This could be, now I'm thinking about Jetson devices, it could be Raspberry Pi plus AI Kit. For the more advanced version, there will be some optimizations regarding speeding, also regarding camera settings, features, and so on. What's important to know about today is that there is something new that I added to the setup, and let me show you right here. So we have a conveyor belt. This is the news because today we're going to do in real time, we're going to simulate a real company scenario where we'll have the products passing here on the conveyor belt. So I will activate this conveyor belt. We can test it with different speed. You can see. I have as object metal steel rings. I have many of them. So you can see, okay, I can put it below this camera. So I have many metal steel rings. We have 6 different sizes of these steel rings. What's the idea in this project? So the setup of this inspection system is going to be very, very basic because we want to make it minimal to achieve our goal in the fastest possible way. So with this, we want to do 3 things. We want to count the objects that are crossing here in the conveyor belt. We want to identify defects on these objects. Now, I simulated, so this is mostly a simulation, so I'm going to simulate defects. So this is the ring that you see. Defects could be scratches, could be this a bit broken. Now I'm simulating, I'm not saying that this will be the real defects for steel rings. This is a simulation so that you can imagine this on any manufacturing scenario. So imagine the most complex defects to identify. That's what we want to reach. To give you an idea of the defects, I'm going now to open the software. So this is what we see from the real camera. We'll get also a bit into that. We have an industrial camera that I connected now to the setup. So let me move myself a bit farther. So maybe I can move on this side. This is now, like, let's do like this. So this is what we see from the industrial camera. And this is the clean ring. Now let me find something with a very, very small defect. So I did some, with a marker, I'm making some very small dots on these ones so that it's very, very small. Okay, you see here, you see there is a very, very small black dot. Now we want to use these as defects that we want to identify. As you see, they are not so easy to identify, these type of defects, but we want to identify them. So there is a representation that if you can identify such small defects on this ring, I mean, we could even identify smaller than this, but this is just to give an idea. Then imagine all the scenarios where you can use this software. So no matter the material that you're using, whether it's metal, whether it's wood, plastic, paper, no matter the type of defects, whether it's a scratch, whether it's some problem with the painting, whether it's of course bigger defects than this, anything that we can see with our eyes, that the camera can see, then we can identify that. We can identify that in real time, and then you can take all the actions that you would like from such detection. So you could have an alert system with a device like HMI, where you can see this alert system in real time. You can have a sound, alert sound. You can send an email. You can block the conveyor belt. These are all the things that we can do. Now let's focus more about what we are going to do today, because there is a lot now that I'm introducing to this, but we need to keep the lives very simple, not too overwhelming, because anyway, this is stuff that takes time. So today we will do something very basic. First, if you have been following till today, if you have been watching the live so far, there is going to be a big change today, because I'm going to refactor the software. I'm going to simplify a lot this software. So now let's go back to a simple camera setup. On the previous version, the software was quite complex. Let me see if I can run that one. So we have two different branches. I have a main branch. So let me now go with the main branch, and let's run the old version of the software. This was the old version of the software. The old version of the software, where we have start collecting images, we can collect data set, we can do the annotation here in real time, we can train the model. So much stuff, really so much stuff. Then we have the settings, simple settings, where we can change camera settings. All of these, I realize it's way too much, especially starting a software with so much stuff when we don't have even the basic covered yet. So like, I have training, I have annotation inside the software, but still we cannot identify defects, we cannot detect anything. So I realized I've been doing the mistake of putting so much all together into a software without getting to the point. So the point of such software is to identify defects, visual inspection system, and I made a big mistake. Let me know, chat, or in the comments if you're watching this video later. Do you do the same? Like you have an idea, you want to reach a goal, and then you get lost into adding so many features because it's cool to have a software that does everything, but then missing the point. And when we build such system, we need to reach the goal as soon as possible. While it's much easier when you have a client that have a specific target, because I build such system normally, build such system all the time, and when a client asks me, I want to visual inspection system, I want to identify this type of products, I want to inspect this, there is not much thinking, oh, let's add this feature, or I go straight to the point. Not great user interface, whatever, not many features, just a window with some ugly looking arrow. I don't think about what color or how to make it look nice. I think, okay, this needs to work, and I will get the work done in as soon as possible. So if I can make it in a few hours, I will reach my goal in a few hours. And so now I'm pivoting the idea of the software, going now straight to this. So this was the old version of the software. We could collect data sets and everything like this. Now let's change this because data set requires to make the software much heavier, more complex, and all the things that regard data set. It's a software that shouldn't be inspection. So for this one, I have already another software. I will show you. So I'm going to somehow combine them. I have this visual label software that it's all for image annotation, for dataset annotation, for training. So we take that on the other side, while on this one, we keep it as minimal as possible because we cannot do dataset and training. Let's say that we want to implement this software on a Jetson device. So the Jetson device to give you, now let me see, I have one Jetson device here. So Jetson device, this is an old one. I will probably buy soon. Okay, now without opening, this is, I'm not going to open out the package, but this is Jetson device, the Jetson Xavier. It's a device that has a small amount of memory, processing power, and so on. We don't want to fill the software with what we don't really need. So this was the old version. So yesterday and the day before, I was working on removing most of it. So I created a second branch, and I call this minimal, where I remove most of the stuff. So we have only the camera display, nothing else so far. And now, in today's live, we're going to use this. I'm going to only add one thing today. I'm going to add the dataset collection, but not training. So dataset collection could be two things. Could be getting video or getting images. That's it. So the conveyor will be moving like this. You see now in real time moving the conveyor. The conveyor will be moving, and while it's moving in real time, we're going to collect images. So let's do that. Now this software doesn't have any dataset collection integrated so far. In the meantime, chat, feel free to write, to ask questions. I'm here to answer any question about this product, or in general, if you want just to ask questions about computer vision, if you want to just chat, I will be happy to interact. It has been always a lot of fun when I do the lives. So we are here now. Let's integrate. So I'm going to use agents. I'm going to use GitHub Copilot Cloud Opus 4.6. It's, for what I've seen so far, the best agent that we have. So let's go with that. And let's now ask, I want one thing. I want to introduce dataset collection. This should work. I can choose two ways on how to collect data sets. I can record a video, or I can save images, deciding on how many frames to skip. So on how many frames displayed to save images. So let's now go with this. I will make plan, so it will ask me a few questions. So we have different options. We have plan, we have agent. Agent will right away work on it. If we put plan, it will show the plan, and so I can adjust based on what the Copilot is showing me. So basically, let me show you what are the ideas right here. So we have, you see, we have now the second camera. Let me switch from the others to the other side. So here the conveyor will be moving. We can record video, so the software will collect the video. Everything that we see right here can be stored as video. That's fine. So because then we can use this video to extract the images to create our own AI model. That's totally fine. But also, video might be very heavy. Video might take so much memory. So if you have limited resources, that's not the best thing to do. So second option would be even better. That's probably what I would use to save images. So let's say every 200 frames, we save an image. We don't need to have an image every single frame, because we will see the same object just in a slightly different position. We don't need that. We need just to have a few images here and there. We need to have as much variety as possible. So we will find a compromise with this. Of course, this depends on how many frames the camera has, on how fast the conveyor is moving. These are all things that need to be taken into consideration. Now let's see what the plan is asking here. Create dataset settings. Okay. Plan dataset collection, video recording, and image saving. Add a dataset collection feature with two modes. Record video, that's exactly what I want. Save a continuous video file from camera feed, and save images captures individual frames with a configurable skip interval. Exactly what I want. So I'm sure now that it's getting what I want. Both modes are controlled from a new section on the home page. Side panel empowered by a new headless dataset service. Awesome. Create dataset settings data class. Create a dataset service as new file. So far I'm very happy. Bootstrap dataset service in main.py. Wireframe delivery main window. Add dataset collection UI section. Update documentation. Further consideration, video codecs default to MP4V for maximum OpenCV compatibility, or use H.264 for smaller files. Now, these are all things that we don't have to implement at the moment. Subfolder structure, should images be saved flat or in a timestamp subfolder? Recommend timestamp subfolder. OK, not OK labeling. The existing storage dataset has OK, not OK folder. Should the collection UI let the user choose which label? OK, only 3. We don't choose any labeling. The dataset collection stores everything together. Annotation will be done later on an external software. So this is the change that we're doing now. No dataset annotation anymore inside this software, at least at the moment. at least at the moment, because we want to keep this as simple as possible. We don't have to complicate anything. So bootstrap, wireframe delivery, so everything should be as it was before with this additional thing that I explained now. Timestamp subfolder, of course, here it will put a lot of further consideration probably. Now, let's start implementation. Let's start implementation. While it is implementing, let me work a bit with preparing the conveyor. So what I will do when it's connecting, collecting the images and videos, the conveyor will be running and I will be putting objects over and over. Some of them I put some defects, some of them don't have defects yet, so I'm going to work on this in real time. I'm going to use a marker. Let me show on the second camera, and this one, white, I don't know how to call this. So I'm going to use these two things to make very small visible defects for our system. So let me place everything. I mean, this can be even random. They don't need to be placed all together. Also, something that comes now to my mind, someone was asking this in the past. They might be overlapping. Like you see, when it comes to counting, sometimes, let's say if the objects are overlapping, that could be something that can be interesting to have in such system, to have a very accurate counting, so count objects even if they are overlapping with a certain accuracy. That's something all that we will discuss. So chat, if you have such question about this, let me know. Also, if you have a company and if you want to integrate such service, despite this software is ready or not yet, I build this software for this system for companies, so always feel free to contact me at info@pysource.com. Also, at pysource.com you find a contact section at the bottom of the page, and so if you want me to help you with your system, to implement such system in the companies, I definitely can do that. Let's now keep all. While if you're interested to learn things about yourself, I also have a community. It's called AI Vision Academy on School. You will find links below in the description. That also you can ask me questions. There are courses from basic computer vision to build computer vision systems. We have Q&A calls and so on. So feel free to check that out if that's something that interests you. So let's now keep all maximum tool attempts reach. So let's click continue. And here, by the way, in the past, the Copilot was asking me a lot of questions like permission, allow this, allow this. I just allow everything now. So I changed the settings because it was so annoying. From the settings, GitHub Copilot, edit settings right here, general. Where was this? Chat. There was here terminal auto approve. I just auto approve everything. Of course, because I'm comfortable that there are no private data on so on. Of course, when you do that, make sure that you know what you're doing. So here I don't have any private data of any client or any data set and so on. So I'm comfortable about auto approving that Copilot can do anything. In my case, of course, you might be careful with that. Now we have the integration of collecting the data set. So let's run this one. Let's see if everything is working, and then we can already start with this. So we have on the right side dataset collection, mode save image, record video. Let's try this. I don't know why the video from the camera disappears, so this is not good for sure. Fail to open device fail to open camera. So I'm not happy about what's happening with the camera. So like here, okay, now camera is working. So Probably it was already occupied from the process before. Now the camera is working. Yes, camera is working. You can see very nice camera, industrial camera. So go for industrial camera when you have to build such system, of course. Where to put the feeds? Now, okay, I can squeeze this a bit on the right. Now let's try the video recording. So let's make sure that things are going correctly. We will try video recording. So start collection, recording frames. Let's start this, and I'm going to put, well, it's going pretty fast now, the conveyor. It's going pretty fast. I could slow it down a bit, just to make things easier for me now. So we have the conveyor right now running. So far we're just collecting the dataset, and we're only collecting videos. There is a test. So let's see what's going. I'm not focusing on any defects or anything, just randomly placing the rings like this. Very randomly. You see we have many different sizes. It will be very interesting to measure them and identify even the smallest defects into this system. It's going decent. It's lagging a bit. I'm not very happy about the frame rate somehow. Feels like it's lagging a bit. That's something that we will see. So conveyor is now moving. We are collecting the dataset. Let me stop conveyor. Let's stop dataset collection. And we should have this in storage and then dataset. So if we go in storage and then dataset, open. Why do we have a database here? Dataset. Okay, not okay. This is from the previous program. We need to remove this. We have video recording. Let's see if we have a good video. Okay, we have the video. So this is the video recorded from the conveyor. Everything is great. So this already, we could use this video, put this video into an annotation software, train our own model, as easy as that. That's it. So the video ready, it's okay. I'm not sure about the speed. It feels lagging to me a little bit. At least it felt lagging with the frame rate. So let me see if there is anything here about settings, about frame rate. 1 frame, okay, we have 30 frames a second. Okay, I see something here. Here, from the settings, we can change. This is something implemented yesterday. From the settings, we can change the frame rate. Of course, like it's even 10,000 FPS. Here, it's totally random, the setting, but let's increase it to 280 if it can handle this. So we can increase the frames. Now, instead of recording video, let's go with save image, and let's save a frame every 300 frames. Let me place something right here at the moment. Let me place stuff, and then I can place them in real time. But now let's have something going on. Okay, ready? Are we ready, chat? Chat, I don't hear you. Let me know if you are following. Feel free to. Where are you from? Where are you connecting from? Let me know that. Here we are live streaming from Sofia. It's 11:29 for me, as you can see from the bottom right of my screen. Usually we have, I usually stream in the afternoon. In the afternoon we have a few different countries. People connect from Europe. I remember mostly France, also South America, Brazil, the last times. So let's start collection. 1 image saved. Okay, it's not saving that much. Nigeria here. I welcome from Nigeria. Don Solo Khalifa 6828. So here, every 300 frames, it's probably too little, saving frames. The problem is that I don't have the frame rate displaying what is the frame rate. I don't want to get lost into too many details, but at the same time, I think knowing the frame rate is something that can help us understand also what's going on with saving frames. So let's ask this. Show frame rate in real time. The frame rate should be real and calculated on actual frames that are being displayed. So let's do that. Philippines here. Wow, we have many, we have new countries today. First time that someone is writing from Nigeria and from Philippines. Welcome, Super Chef Yu Maunxing. Welcome to the live. Are you guys enjoying it so far? I'm trying to keep this not too complex, not to get lost into too many technical things that are not understandable and that don't make sense I believe. I'm trying to be as practical as possible, but I want to be simple and practical, but at the same time, I want that this simplicity is useful. So that's my goal, and if I can achieve this, I'm super happy. Okay, I'm doing some change. I forgot to commit the previous change. It's a good practice to, when things are working, to save and commit the changes. I forgot, so I hope that it doesn't mess up with these new changes. So after we're done with dataset collection, we can move to collecting the images. Oh, thank you. Going good so far. Simple and practical. I like that. I'm learning a lot. Oh, awesome. That's my goal. So I'm very happy to hear this. So let's start. Let's start this. Okay, we have now the real frames per second. It's 19. So now we have FPS. Now let me commit the changes. So changes right here. What did we implemented? Okay, you don't see it. I'm doing the committing here on the left. So what did we do now? We added dataset collection, video and images. That's it, as simple. So let's commit changes. Let's push the changes. Added, pushing, done. Done. So now we go back to monitor plus to cameras. Let's close this one. What camera are you using? Basler? No, I don't know this Basler. I'm using Daheng Imaging. Is a Chinese brand. Let me show you where. Let me show you Daheng Imaging camera. I'm not sure. Okay, this is where I got it from. Just to be clear, I have no sponsorship or anything with this vendor. Just that's what I found where I got this camera, and I'm happy with it. So I'm happy to share it with you. So industrial cameras, Jigetsu, this one. It's one of these cameras right here. I don't remember which one. I will have to read the model, but this is the brand. So I took one camera and then I took the non-distortion lens. So it's an industrial camera. You can choose, when you get industrial camera, the frames a second that this camera can reach, the aperture size, the shutter, rolling shutter, global shutter, and color, black and white, and so on. So this is the camera that I'm using at the moment. I think that you can see, where is this? Okay, this. So this is, you can see this is the camera right here. It's connected via Ethernet to my router. And the Ethernet is already providing also the electricity to run the camera. You said it was industrial camera. How does that differ from a basic camera? Well, industrial camera, you can definitely get a much more advanced specs. So with industrial cameras, you can choose. First of all, they are more solid cameras, so you cannot use webcam or just any simple camera in industrial settings. So they are more solid cameras. They have the Ethernet connection. So even if you have to put the camera 100 meters far from the server, you can do that because you can use very, very long cables. You cannot do this with a USB camera. On some USB camera, like 2-3 meters, and then the USB will start giving problems. But also industrial cameras, all the settings that you want to get. So you can get 5, 10, 20 megapixels, how much you need in resolutions. If you need frames per second, you can get hundreds of frames per second. You can choose the aperture of the lens, so how much light will enter inside the camera. And here also, now it's not visible, but I can regulate the settings of the camera, so I can choose how much light I can enter, how to focus properly. So with the industrial cameras, you can get very high resolution when you need to work with visual inspection. Do you need industrial camera? Absolutely, not always. I have some guy in the AI Vision Academy. One member is doing amazing stuff with a simple Raspberry Pi with an AI kit, a Raspberry Pi camera, so super basic devices, and is getting like super high frame rate with a very simple setting. So, and is using this in production in the company. So if you want, you can also use small setups, whether you can, it could be a webcam or a Raspberry Pi camera. It could be everything working instead of server working on a simple desktop device or a laptop. So you are free to do this. So the camera setup and everything, it's of course a friction to use such system, but it's not necessary if you don't have to. Of course, it's recommended for obvious reasons, and most of the time you might need industrial camera. But if you have to do simple checks, you can do that with very simple setups. Another guy also in the community, in the AI Vision Academy, around a year ago, made another system working in production, running on a Raspberry Pi with a very basic setup without even using AI. It was just checking difference of the color. So he had a conveyor, black conveyor and boxes. It was without AI, just filtering the colors, and he could detect the boxes from that. So I'm here always go for simplicity. That's what I will do. So now we are displaying the frames per second right here. We committed the change. So we have 18, 19 frames a second, which is pretty bad. Why we have such a low frame rate? This software might need some optimization, of course. Now imagine that there we need some multi-threading to analyze, to get the frames. I will not get lost now into this, but we're getting a low frame rate. So since we're getting a low frame rate, you see on the right bottom, let's save an image every 20 frames. So we see we have around 20 frames a second. So if we save an image every 20 frames, it means that we are saving one image per second. I think it's fair. So let's do that. Now, are you ready? Chat, are you ready? We're going to start collecting the images. So I will be here on the conveyor. I will be putting the products and we will be collecting them. So I will spend a few minutes with the conveyor right there. Okay, let me put something for starting. Right here. Just a few. Actually, we could even say less than one every second, but whatever. Let's go for it. Oh, I have one super small. Can you see this? We have 6 sizes of these steel rings. We have very, very small of them. Will be also good to detect the sizes. That will definitely be implemented in this system. So chat, I will prepare this, and we prepare dataset collection. Let me see if the previous one was working. We have images. Here the dataset collection was working pretty well. So that's all we have to do. Let me remove this, and now 1 every 20 frames. Are you ready, chat? I'm starting with the collection. So dataset collection, and here to make some defects, and let's go. We have the conveyor. I will make it run quite slow, so I'll put stuff with defects. I'm going to make defects in now so that we have some more samples with defects, and these are going to be very small defects. You will see now, okay, the black dots, that are defect that we will identify here. They're very small. I'm going also to put things without any defect. I'm going to put also white, very small visible. Let me see if you see this white that is coming. So from this, there should be some white in some of them, just barely visible, because we want defects that are not easy to identify, because this system needs to be better than the human. It may need to work in real time better than the human, so we need to give the system some challenge with some hard to identify objects, very small. If I can even catch them, I'm not sure I can catch them. Okay, I can. Okay, there are some small ones. Okay, this one will be nice to see if we can see that. I will be very curious to see, because the camera setup can anyway be also improved. Now, there is a very small one. Let's see how is that one going. Okay, okay, there is a black dot. We see the black dot right there. We see the black dot here, this one. Chat, if you're joining now, this is all about dataset collection. So the system, of course, now it's collecting data for us. So we don't have yet a real-time detection, but that will happen. That will happen soon. Not in today's live, but soon you will see the system in action. So stay tuned also for next live, because this is going to be very interesting. We will develop this system. I'm putting different type of objects, different defects, some objects with the marker, some objects without the marker. Let's put some white. I'm curious to see if white is visible from the camera. It's barely visible to me. Okay, this one, it's just a little bit. Can we see? Okay, there is a bit of white, we can see it. Then this. Okay, I wonder how many images did we collected. Now, of course, data set, normally the more we collect, the better, especially if we have some very complex to identify defects. If we have some very hard to identify defects, we can do that. So But if they're very simple, we will need just a few dozen samples. Well, while I'm trying to identify defects, I see that there are already scratches in some of these. So actually we only need to simulate defects because some of them are pretty scratched. But I don't have many of them scratched. So today I'm making very simple, like hard to recognize, but marker signs. So that's not the type of defects you will normally see in such scenarios. But now, of course, this is a demo for simplicity. I want to show you how things work. And then later we can work on real use cases. For the moment, let's stick with what we have right here. Okay, like this. Just a few more and I'll be done with the dataset collection. Let's go with these two, some without any problems, like this. Also because we can, of course, measure the sizes of this. So it's not only about detecting defects, but also size measurement. So let's do this. We have a few more. Let's put some more white of this. Can you see the defects or not? Can you even spot the sign, the white sign? Okay, you see this white is very visible. The other white, there is another one small coming. Okay, you see there is some white, it's quite visible. So the system will definitely have no problem identifying this. One fell on the floor. Okay, let's go with next one. Let's put a few random right here. Let's put more. Let's put more. Okay, like this, like this, like this. Some more sign. I'm trying to make some very, very small dots. Very small. So that we challenge the system. So this data set is going to be very interesting. Like this. Some more. Okay, this one has some scratch by default. Of course, this is going now to be very, very basic and simple. Okay, how many samples do we have? We have 400 images. Well, I think 400 images is pretty good. Okay, last few, and then I'm done with the collection. Let me put some white in some of them, like this, and some of them white and black also. Okay, like this, some black. Okay, these are all dirty with, let's say, defects, like this, and like this. And we should be good with this. Let's now finish. You see there is some black dot, white, here a super small black dot. We will see this when we increase the size of them. It will be interesting once we increase the size of them. And let's stop collection. Okay, first I will stop the conveyor belt. Let's stop collection right here. 495 frames saved. Infa made off. Am I able to join your academy knowing no pi? What should I learn before joining? Okay, I will say no. I will say I have also very basic versions that start from using Python, loading the image. You can step by step understand, but I highly recommend to having some knowledge of Python before joining, because otherwise it might feel overwhelmed unless you already know some other programming language. Because of all the members that we have, so many don't know Python, so many they are beginner in Python, but they are coming from a different language, they already know programming in general, so it's okay. So what's your background? So if you're already familiar with programming, with the logic of programming, then if you don't know Python, it's not a big deal because you can learn the basics of that. But if you are completely new, I recommend to start studying Python. There are so many tutorials on YouTube for Python programming. And the basics are not huge. So these tutorials on YouTube, there are many free tutorials from many creators, and in 2 hours they cover all the basics. So you study this 2 hours tutorial from YouTube, Python basic tutorial, you practice that one. Once you're comfortable with that, then I would say then yeah, you can join the academy. Before that, it will be overwhelming, so I don't recommend it. Now, we collected the data set. Let's see how are our images. So we have a pretty decent data set, I will say, 400 plus images with so many objects. It's decent, it's not huge or great or whatever. Let's say it's decent because we have quite enough number of objects. And I'm going to investigate some of them. So thank you, you're welcome, Infam Adolf. Let's see, and the images, they look pretty good quality. How much is the Academy now? The Academy is $49 per month. Or if you join yearly, you will have some discount, like 3 months. We will have 3 months free. So, and you can anyway enter and leave anytime. So if you're not sure, you can just try even for 1 month and see if it's something that's good for you. And in the Academy there are many lessons. So you will have lessons from beginner level to more advanced level where you can build systems. First, you can learn everything that regards image processing to process images with Python. Everything it's covered there. But also you will learn how to train your AI model, how to build your system to detect, segment objects, track objects, and so on. But the best part of the Academy is the community access. So there is a community where I'm there every day. So you can post your questions there. You can, you can ask general things about whether it's your project or general questions about computer vision. And once a month, we're going to have a Q&A call where we usually meet a few members, of course, who has time joins there, a few members where we chat, we discuss about our projects, but also we dive deeper into your project. So if you are struggling, if you have a goal, you want to build some specific projects and you are struggling, that's the moment where we can get into that and I give you my personalized feedback about your project. Next call is tomorrow. So I don't know if now anyone from the community is following, but tomorrow at 1 p.m. UTC time zone, we're going to have our Q&A call for March. Now, I'm analyzing here the data set. So let's go like this. The quality is decent. It feels that it's a bit blurry. It's a bit blurry probably because of the camera settings that I gave. So maybe it wasn't the best idea to start collecting the data. I mean, we can see. So you see now there is some black marker that I put on the object. Generally, today's dataset labeling, if good or not good. Today we haven't done any labeling so far. So this is going to, today we only took the images. So what we will do from this, we will use a software to segment everything that's right here. And then from that we can train our own model. Do you chat, are you chat interesting to see also these steps? I'm not sure if I should put them in a live or not. I was thinking I will get done with the dataset labeling and training because it's a long, probably boring step. I'm not sure it's interesting for the chat. I can show a summary, or let me know, chat, if you want also to see these labeling steps, and I can just walk you through while I'm labeling this. But generally, with this dataset today, we're going to achieve mostly two things. First, detect the ring. That's the first. And second, yes, we can say good or not good. So this one, when we have the clean ring, it's good. When there is some marker, like here we have the black marker, then it's not good. What I don't like now about this is that I could have set it up the camera a bit better, but still it's okay. I mean, we see everything. It just looks slightly blurry to me when I zoom this. But anyway, I would say that's good enough. So for today we have dataset collection. I'm pretty happy with this. And chat, as I said, I don't want to overcomplicate the system any longer as I've been doing so far. So I don't want to put too much things at the same time into one live. Just to some recap, here is the system on github.com. So we have InspektLine. So I'm sharing here now in the chat where you can find the system. I'm not sure now you have access to, to branches, minimal. So you can put a star right here if you want to be updated to about this system. It's open source, as you can see. And I will be building this live by live. So my last question to you, chat. Do you want to see also dataset annotation or we should skip already to the model, so to the real-time detection of the model? So that's, based on this, I can think how to structure the next lives. A browser internet channel. Oh, awesome, cool. Oh yeah, you will find a lot. You will find a lot in the channel. You will find a lot of stuff. I will give you some. Here you see we have so much stuff about tracking, about detection, about making faster detection, about counting objects in real time, tracking, detecting small objects with accuracy. So there is a lot of stuff if you are interested in computer vision. I think you understand the library. You put it in a box, right, and put a name on it. Exactly. Let me see if now I'm working on library software. Let me see if I can run it now. I'm not sure I have it in this computer right now, so let me run this. I'm just not sure it's on this computer, but it's not. No, I don't have it now, so I cannot display it in this moment. But yeah, I might display that shortly in the next video, in the next live, or in a dedicated video. So I can just thank you, everyone that has been following the live so far. I'm going to do more lives and bring more content on YouTube, so make sure that you subscribe to the channel Pysource. Subscribe. If you hit the bell, you will be notified when we're going to have the next live, and I will post something more about when we're going to have the next live. And soon I'm also working on a new video that will come soon to the channel. Thank you everyone that's been watching. This is all for this live. See you in the next live.